Vision testing has two basic components. One is visual acuity, high contrast measurements that tell us about whether or not you can read detail, and it's very important. But the other side of vision, contrast sensitivity, is equally as important, if not more important, because it's our get-around vision. Contrast sensitivity testing today has been done with vertical sinusoidal gratings, which was a big advancement 20 or 30 years ago. But refractive errors and aberrations of the eye end up being things that are not rotationally symmetric. And what that simply means is when you look at a starburst or some pattern, instead of seeing all the lines equally dark, some of them are darker than others. So when we show a vertical sinusoidal grating, those people that see vertical lines clearest end up doing better than those that don't, and that shouldn't happen. We want people, no matter what the axis of their astigmatism or other aberrations, to end up with the same performance if the magnitude is the same. Well, the HACS system does that. The HACS system actually has a rotationally symmetric bullseye that is sinusoidal from the center to the periphery. And when we look at that, as shown here, that sinusoidal bullseye makes everybody on an equal playing field in terms of the results that they get, no matter what the axis of their astigmatism or higher order aberration. Now, in addition to that, we've calibrated to that system with very good studies from different investigators that show us exactly what the performance should be at each of a half, 1.5, 3, 6, 9, and 18 cycles. But it turns out that at the 3 and 6 level is the ones that are most important to people in terms of really measuring quickly the performance of the eye in terms of contrast sensitivity. The other thing about the HACS system, it's been designed in a way to be efficient. It's been a rapid test, and what it does is it allows us to get down to a sensitivity that exceeds any other contrast sensitivity device that's made. It gets down to 1/10 of a log unit, or what we would call 1 dB, where other systems are at about 3/10, which is not enough to show the differences in some of the systems that we have today that measure visual performance. So the HACS system is the best for all types of refractive errors and aberrations, giving us an equal platform. And the second thing is it's calibrated in a way that makes it efficient in your practice, and in addition gives us the best results for all spatial frequencies, as in the system that basically is the gold standard for today.